Morning, ladies and gentlemen. Today we're doing this problem. It's the aluminium rod AB has a modulus of rigidity 27 GPa, is bonded to the brass rod BD with a modulus of rigidity 39 GPa. Note that the portion CD of the brass is hollow and has an inner diameter of 40 millimeters. Determine the angle of twist at A. Now here we have the image. The image shows torque at A, torque at B. It also shows the lengths at each consecutive portion and the diameters here. Remember, in the final, inner diameter is in the question. Now, before we continue, the formulas that we use are outlined here. So the angle of twist is equal to the sum of the torques times the lengths divided by the modulus of moment of inertia multiplied by the modulus of rigidity. Now that sum of means you do sections A to B, B to C, C to D. And each one of those individual components, you add them together in order to get your final angle of twist. And then the other formulas we need are the formulas for the moment of inertia. Moment of inertia when it is solid is pi on 32 diameter to the 4. And moment of inertia when it's hollow is pi on 32 diameter 2 to the 4 minus diameter 1 to the 4. Okay. So first we will move on to finding all these individual values for section A. So the first thing we'll do is torque. So we can see that we have TA here on the image that is has 800 Newton meters. That means there must be a reactive torque when we cut it just slightly past for it, and we'll call that torque TAB. Now, when we do the sum of moments and we define moment to be positive into the clockwise direction, we'll identify that here torque is negative, TAB has to be positive because it's reacting to the negative torque of TA. Therefore, TAB will equal to 800 Newton meters. Now, the moment of inertia, because this is a solid shaft, it's simply pi on 32 and then the diameter of that shaft, which is 36 millimeters or 0.036 meters. And then we'll get that value here. The length is 0.4 meters, and the modulus of rigidity is given in the question, 27 times 10 to the 9 pascals. Giga means 10 to the 9. And next for section BC, we do exactly the same thing. We just cut a little bit further up the shaft, and we have torque at A, we have torque at B, all spinning anti-clockwise, and then torque BC is a reactive torque. It will spin clockwise. So sum of moments define the positive direction to be clockwise. So T minus TA minus TB plus TBC equals to 0. And then when you add 800 Newton meters and 1,600 Newton meters, you will get 2,400 Newton meters. Then moment of inertia, same as earlier. It's a solid shaft from B to C, still solid, so it will be just pi on 32, but the diameter will change. It will just be multiplied by 0.06 meters to the 4. The length slightly different again. It will be 0.375, and the modulus of rigidity will be for a brass rod this time, which will be 39 times 10 to the 9 pascals. Now section CD, as we can see in this image, there's no other torques external torques being applied here. So if we cut it, this beam just slightly here, there will be no new torques acting on it. So therefore, torque BC will equal to torque CD, which will equal 2,400 Newton meters. Now the modulus, the moment of inertia, hollow this time, because we're accounting for the hollow component of that shaft. So it will just be pi and 32, 0.06 to the 4, which is the outside diameter of that shaft, minus 0.04 to the 4, which is the inner diameter of that shaft, getting you that value. Next, the length will be 0.25 of a meter, and then the modulus of rigidity will still be for brass. Now that we have all these values here, we need to solve for angle of twist AB, BC, CD, as identified using the values from the sections here. And it's just a plug and play scenario here. So if you have a look, it's angle of twist for AB will equal to 0.07187 radians. Same for angle of twist BC, which will be 0.0184 radians. Angle of twist CD will equate to 0.01507 radians. Now, if you pay attention to the sum of, meaning that if you add all these individual values, you will get the total angle of twist at A. So once you add all these together, you'll get 0.10506 radians. However, if we want to, for ease of reading, if we want to figure out how many degrees that is, we simply multiply that total value by 180 divided by pi to get degrees. Thank you.